Hello everybody. In this video we are going to talk about rationalizing two-term denominators. So let me give you an example of what we're dealing with here. 8 over 1 minus the square root of 5. We want to rationalize this. This is not a rational number. It has a square root of something that can't be simplified. So definitely not a rational number. How do we make it a rational number? Well, there's a trick to this, and it's not obvious, but once you see it, you realize it works. So that's why we call it a trick. And it gets us to where we need to go, and that's what's important. So what we're going to do is we're going to multiply the numerator and denominator of this thing by something that's going to make this a rational number. Now, what would that something be? Well, let me try to explain how you might come up with this. You might be thinking, okay, when I was thinking about polynomials, this is like a binomial here. I remember that there was a special kind of binomial that when you multiplied it by something, got me something involving squares only. And so it was this. If I have a minus b times a plus b, how does that multiply together? Well, if you multiply this out, you get a squared minus b squared. This is a difference of squares, they call this. This is one of the factoring techniques we learned. Well, look at this. Look what happened. On the right-hand side, I have perfect squares. So you see, if either a or b is a square root, I'm going to be squaring them. The square roots are going to go away. Because if you square a square root, the square root's gone. So this is a great thing to try. So that's what we're going to try down here. Here I have a minus b. So what I'll do is multiply by a plus b. So 1 plus root 5. There we go. And that should give us, that should get rid of the square roots in the denominator. Let's see how that works. In the numerator, I'm going to have 8 times 1 plus root 5. So we'll distribute this. So it's going to be 8 plus 8 root 5, okay? Denominator. Well, look, here's my formula. You can multiply this out term by term, but just look at the formula. The formula says that if you have a minus b times a plus b, you get a squared minus b squared. So we know what this is going to become. It's going to become 1 squared minus root 5 squared. Well, that's nice because 1 squared is just 1, and root 5 squared is just 5. Oh, and I can simplify this. 1 minus 5, let's go to the right here, so save some paper. 1 minus 5 is negative 4. And now I can simplify. Now be careful with this simplification. I see a very common mistake. People will say, oh, 8, 4, cross them out, all right, and reduce this. Doesn't work that way. To be able to cancel, you need to make sure that you're canceling a factor. 8 is not a factor of the numerator. Well, it is, but you have to factor it out first, right? Before you have to write it as a factor, which means write it as in a product. And right now it's a sum. Okay, so that's what we have to do. Factor out the 8. 1 plus root 5. And now, because it's a factor, it's written as a product, now I can cancel these. So I'm dividing the numerator and denominator by negative 4. 8 divided by negative 4 is negative 2. Negative 4 divided by negative 4 is 1. So anything divided by 1 is just itself, so I'm done with the denominator. It's gone. I get negative 2 times 1 plus root 5. You might write it this way, or you might distribute the negative 2 through. Oops, that should be a minus. Oh boy, there we go. Or you can write it like this. Either way, either or, depends on who asks you for the answer and what kind of answer they want. But the real trick here was multiplying by this thing. What is this thing called? Well, all we did was we took this expression and we changed the minus to a plus. That's called the conjugate. And so to rationalize two-term denominators, the trick that we're using here is called multiplying by, oops, it's a J, conjugate. That is the star of the show today. This is the trick that gets us to a rationalized denominator. Let's just do one more to make sure we've got this all straight. Okay, let's try square root of x plus root 3 divided by the square root of x. Oh, let me change this. Let's make this a minus and make this a plus, because I want it to be different than the last example. So square root of x minus root 3 over square root of x plus root 3. Let's see what we get here. Okay, well, what was the trick? Multiply by the conjugate. What's the conjugate of this? It's where we change this to the other sign. So if it's a minus, you make it a plus. If it's a plus, like we have here, you make it a minus. So I'm going to multiply the numerator and denominator by square root of x minus root 3. Okay, what do we get? Well, in the denominator, we know what we get. Remember, a plus b times a minus b is a squared minus b squared. You could multiply this all out and simplify, you'll see you get this. But we know that that's that from the formula. And what happens in the numerator? Well, here we have a minus b times a minus b. What was the formula for that, if you recall? I'll write it up here. A minus b times a minus b. You might remember, you can work this out on your own to be sure, but it's a squared minus 2ab plus b squared. That's the formula for that product. So let's just use that. It's going to be a squared, so square root of x squared, minus 2ab, so minus 2 root x root 3, and then plus b squared, so plus root 3 squared. Okay. All right, let's clean this stuff up. In the denominator, square root of x squared, well, that's just x. Square root of 3 squared is just 3. Well, isn't that nice? We've rationalized the denominator. Good job, us. But let's finish up this numerator. We have to simplify things to be done. Square root of x squared is x minus 2 root x root 3. Well, I can write this a little bit nicer. I can write that with a single radical. X times 3 is the same thing as 3x. And then what about root 3 squared? Well, square root of something squared is just that something. And it looks like that's all we can do here. That's it. All right.